Have you ever wondered how the universe came into existence? It's a thought that has crossed our minds at some point, isn't it? Well, today we're going to dive into one of the most intriguing scientific propositions that seeks to answer this very question: the Big Bang Theory. This isn't just a theory, mind you, but a well-substantiated explanation of our universe's origin. The term Big Bang might conjure images of a massive explosion, but it's more about a moment of creation, a point from which all matter, energy, space, and even time itself began. This theory paints a picture of our universe's journey, starting from a singularity, an infinitesimally small and infinitely dense point, to the vast cosmos we observe today. So get ready to embark on a cosmic journey, a voyage through time and space, as we unravel the mysteries of the Big Bang. Remember, the Big Bang Theory is not just a theory, but a well-substantiated explanation of the universe's origin. Understanding the Big Bang Theory starts with understanding the concept of singularity. Now, what is singularity, you might ask? It's a term that might sound complex, but it's really not that hard to grasp. In the simplest terms, a singularity is a point where certain measures become infinite. Sounds mind-boggling, right? But stick with me. Now let's apply this concept to the universe. Picture the universe, vast and full of stars, galaxies, and everything you can imagine. But rewind time, way back, about 13.8 billion years ago. The universe, as we know it, wasn't spread out like it is today. In fact, it was squeezed into a single point of infinite density and temperature. A singularity, this was a point so incredibly small, it was tinier than an atom. Now you might be thinking, how can something so vast as the universe come from something so tiny? Well, this is where the magic of the Big Bang Theory comes into play. This theory suggests that the universe we know and love today started from that infinitesimal point. A point so small, you could fit it on the tip of a needle, yet so dense and hot, it contained all the matter and energy that would eventually become everything we see in the universe today. The Big Bang Theory doesn't just propose that the universe expanded from this point, but rather it burst forth. Like a cosmic firecracker, this singularity exploded. The explosion was so immense, it set the stage for the universe to evolve into the vast, diverse expanse we see today. And this wasn't just any explosion, it was an explosion of time and space itself, creating the very fabric of our universe. So in essence, the Big Bang Theory is a story of how the universe went from a singular point of infinite density and infinite temperature to the wide, sprawling cosmos we see today. A story that starts with a singularity. This singular point, which was smaller than an atom, exploded and led to the birth of the universe. There are several pieces of evidence that support the Big Bang Theory. Let's first take a look at the redshift of galaxies. When we observe distant galaxies, we notice something peculiar. Their light isn't quite the same as it would be if they were stationary. It's shifted towards the red end of the spectrum, which in the realm of physics indicates that they're moving away from us. This phenomenon, known as redshift, suggests that the universe is not static, but is in fact expanding. This expansion is consistent with what we would expect from a universe that began in a Big Bang. Next, we turn our attention to the abundance of light elements. The early universe was a hot and dense place, much like the core of a star. Under such conditions, the building blocks of matter, protons and neutrons, confuse together to form heavier elements. Scientists have calculated that in the aftermath of the Big Bang, there should be a specific ratio of light elements such as hydrogen, helium, and lithium. When we look out into the universe today, we find that this ratio matches our observations remarkably well, providing compelling evidence for the Big Bang Theory. Finally, we come to the cosmic microwave background radiation. This is the afterglow of the Big Bang, a faint whisper of radiation that fills the entire universe. Discovered by accident in the mid-20th century, it provides a snapshot of the universe just a few 100,000 years after the Big Bang. The existence of this background radiation and the specific pattern of tiny variations within it are exactly what the Big Bang Theory predicts. These pieces of evidence, the redshift of galaxies, the abundance of light elements, and the cosmic microwave background radiation, point to a universe that originated from a single point and has been expanding ever since. The Big Bang Theory has profound implications for our understanding of the universe. It is more than just an explanation for the beginning of everything. It is a lens through which we can view the cosmos, helping us unravel the mysteries of space and time. One of the most profound implications of the Big Bang Theory is the realization that our universe has a finite age. Before this theory, the universe was often considered eternal and unchanging. The Big Bang Theory changed this perspective entirely. It suggests that the universe came into existence approximately 13.8 billion years ago. This idea was revolutionary. It challenged our understanding of the cosmos and brought forth the concept of cosmic time. Another implication of the Big Bang Theory is the understanding that our universe is in a constant state of expansion. In the early moments following the Big Bang, the universe began expanding rapidly and has continued to do so ever since. This expansion is not just happening at the outer edges of the universe, but in the space between galaxies, between stars, and even between planets. This theory also has implications for the future of the universe. As the universe continues to expand, it's predicted to undergo various stages, including a potential big freeze, big rip, or big crunch. These are all theoretical scenarios for the ultimate fate of the universe, each one as fascinating as it is terrifying. The Big Bang Theory also has philosophical implications. It has changed how we perceive our place in the universe. If the universe had a beginning, then it's reasonable to assume it might have an end. This introduces existential questions about our purpose, our future, and the meaning of life itself. The Big Bang Theory is not just a scientific theory, it's a story of creation, of beginnings and potential endings, of cosmic life and death. It's a story that connects us all, from the smallest particle to the most distant galaxy. The Big Bang Theory has revolutionized our understanding of the universe and our place in it. It has challenged our perceptions, ignited our curiosity, and continues to inspire us to explore the cosmos and seek answers to the universe's biggest questions. Despite its wide acceptance, there are several common misconceptions about the Big Bang Theory. So let's unravel some of these misconceptions and set the record straight. The first, and perhaps the most common misconception, is that the Big Bang was a massive explosion. That's not quite accurate. The term Big Bang might evoke images of a colossal fireball, but in reality it was more of an expansion of space rather than an explosion in space. Think of it as the rapid stretching of an elastic band, not an explosive detonation. Next, there's this notion that the Big Bang Theory explains the origin of the universe. Well, that's not entirely true either. The Big Bang Theory describes the development of the universe from a tiny, extremely hot and dense state to the vast and cooler cosmos we see today. It doesn't attempt to explain what caused the initial state or what was before the Big Bang. It's more about the evolution of the universe, not its ultimate origin. Another misconception is that the Big Bang Theory is just a theory, implying it's a mere speculation. In scientific terms, however, a theory is a well-substantiated explanation of some aspect of the natural world, based on a body of facts. So when we say Big Bang Theory, we're talking about a well-supported scientific explanation, not a wild guess. Also, some people believe that the Big Bang Theory contradicts the principles of conservation of energy and matter. But the truth is, these principles apply to isolated systems where no energy or matter is added or removed. The universe, however, is not an isolated system. Lastly, there's a misconception that the Big Bang Theory claims everything came from nothing. In reality, the theory doesn't exactly say this. It posits that the universe began from a state of extreme density and temperature, not from nothing. Understanding these misconceptions can help us have a clearer understanding of the Big Bang Theory. The Big Bang Theory is a fascinating and complex theory that has changed our understanding of the universe. We've journeyed through the cosmos today, exploring the very foundation of this theory, a singular point of infinite density and temperature that exploded and expanded to create the universe as we know it. We've examined the compelling evidence that supports this theory, from cosmic background radiation to the redshift of galaxies, affirming our cosmic origins. We've also delved into the profound implications of the Big Bang, challenging our perception of time, space, and reality itself. Along the way, we've debunked some common misconceptions about the Big Bang Theory, reminding us that it's not about an explosion in space, but rather an expansion of space itself. While the Big Bang Theory is not a complete explanation of the universe's origin, It provides the best explanation we have based on the current evidence. So keep exploring, keep questioning, and keep looking up to the stars.